today we'll be presenting our mini lesson on balancing equations and types of chemical equations.
Greetings, my name is David Reyes and I will be presenting on synthesis reaction. Now, what is a synthesis reaction? Well, a synthesis reaction is basically a chemical process where two or more simple substances, like elements or compounds, combine to form a single, more complex product. The general equation here is as stated, and A and B are both reactants, plus means combine with or reacts with. The arrow means produce, yields, or forms. AB signifies the final result that is formed. Then we have some common examples here. We have sodium mixing with chlorine gas to form sodium chloride as a solid. And then we need to know how to actually balance these, because we have hydrogen gas and oxygen gas coming together to form liquid water. But how do we get to that point? Because we need to make sure that the same number of oxygen on the left side is the same number of oxygen on the right side, and same for the hydrogen. As we can see on our left, we see that hydrogen has the same number on both sides, but oxygen has only 1 on the right side instead of 2 on the left side. Now, to balance it, we will actually add a 2 to the H2O, so there will be 2 oxygen on that side, but that means there's gonna be 4 hydrogen on the right side as well, which means we also need to add a 2 on the hydrogen gas on the left side to make it completely balanced, and then we have everything right here. Now, here is another example. We have sodium and chlorine gas form sodium chloride as a solid, and then here we see that sodium is equal on both sides, but chlorine, there's 2 chlorine on the left hand side but only 1 chlorine on the right hand side, so we would also need to add a 2 in front of sodium chloride to make there be 2 chlorine on that side. But then we also have to add a 2 on sodium on the left side, because then we need to make it equal. So 2 sodium on the left side means 2 sodium on the right side, and we have the final answer right over here. Now, for the final practice, we would like to balance the following synthesis reaction. Now let's review the answers. We've gone on to some key points to remember when you're done with this. A synthesis reaction is when 2 or more elements or compounds that join together to make a more complex product. Remember, when predicting the product to take into account charges, remember those. And then look over solubility rules when inserting the stick, because you need to remember which ones are actually aqueous or whether they're solid, liquid, or gas. Now, when balancing, ensure that the same number of element are on both sides. So there's 2 nitrogen on the right side, there has to be 2 nitrogen on the left side. Now, thank you for listening to this presentation.
Next, we have our decomposition reaction. A decomposition reaction is when a single compound breaks down into 2 or more substances. So we can give it a general form of product AB breaks down into product A and product B. Alright, now that we know our general form of a decomposition reaction, let's run through a quick example. Here, we have H2O, which is a liquid, breaks down into hydrogen gas and oxygen in an electrolysis reaction. So when electric current is run through water, it breaks down into hydrogen gas and oxygen. So the state symbols would be G and G. And H2O is just a liquid. However, the law of conservation of mass states that mass cannot be created or destroyed. Mass can only be converted into another form. Therefore, we must balance this equation. On our left side, we have 2 hydrogen atoms. On our right side, we have 2 hydrogen atoms as well. However, we have 2 oxygen atoms on our right side, but only 1 oxygen atom on our left side. So let's go ahead and make a 2 right here to balance oxygen. However, when I do that, it turns the amount of hydrogen atoms into 4. So I have to go back on my right side and add another 2 to balance the equation. Now, try these following questions.
Alright, today I will be covering combustion. But what is combustion? Well, it's basically the burning of a substance, especially the organic material. Like, the most basic formula for it is organic material or molecule slash molecule with oxygen. And then the resultant will always be carbon dioxide and H2O. This will always be in a gas state, and this will also be in a gas state. Of course, oxygen is always a gas, and this is whatever the material is. For example, if you get something like methane, CH4, butadiene is always going to go to some O2. And then they're always going to have carbon dioxide, H2O. Left is the balance. And like I said, matter cannot be created or destroyed. So the balance it gets, this has 4 hydrogen and this only has 2. Is the balance. So we have 1 carbon on this side and you have 1 carbon over here. So keep it. And then for the hydrogen, there's 4 over here and only 2 here. So what times what makes 4? 2 times 2, 4. And now all you have to do is reverse this and you get the molecule. So there's 1 or 2 molecules, so that's 1. And there's 2 into that, that's also 1. That's 2. That's it. Now try these following questions.
Good morning, good afternoon, or good night, Ms.Sosa. This is my presentation on single displacement reactions. This is my contribution to my group's chemistry test, and I will be covering the definition of a single displacement reaction, an example that I will do, and I will also give another example to the audience. Please enjoy. Moving into my presentation, single displacement reactions. Now, what is a single displacement reaction? A single displacement reaction, which is also called a single replacement reaction, is what occurs when one element in a compound replaces another element. This happens because the element that is doing the replacing is more reactive than the one being replaced. So I will give a very basic example with no state symbols or no actual elements. I will only be using the letters A, B, and C. So moving into it, we have AB plus C will react to give us A plus BC. So as you can see, no pun intended, C replaced A. It displaced A. So this is a single displacement reaction because only one element was displaced in the entire reaction. This is the basis of single displacement reactions. Now, moving into an actual single displacement reaction with balancing and elements and state symbols, we have magnesium, which is a solid because it's a group 2 metal, and 2HCl, so 2 hydrochloric acid, and it is aqueous because, for one, chlorides are soluble and everything in group 1 is also soluble, so it's aqueous. So when this reacts, it forms magnesium chloride, which is aqueous due to the chloride being present, which makes everything soluble, and hydrogen, which was being displaced in its base form, is just a gas. So as you may notice, there's 2HCl on this side. So on this side you must have Cl2 and H2 so that they balance out, because what you have on one side you must have on the other, and along with the magnesium, which is just 1, this is balanced. So now I'll be giving an example for the audience to do. So here we have zinc, which is a solid, and copper sulfate, which is aqueous due to all sulfates or most sulfates being soluble. I'll give you all a moment to see what this makes. Alright, so moving to the solution, the zinc displaces the copper and it becomes zinc sulfate plus copper, which in its base form is a metal, so this becomes solid. And since most sulfates are soluble, including zinc sulfate, this remains as aqueous and there is no balancing that needs to be done because this is already balanced. Thank you for listening to my presentation.
Now I will be teaching you double displacement. So the basic concept is AB plus CD results in AB plus C. Now the reason for this is because A might be more reactive than C, so we'll take D away from it, resulting in AB. And then the two remaining parts will then become 1. So B will go with C, so then BC. Now, just to clarify, sometimes there can be a possibility where C is more reactive than A, which will then just make it no reaction. It will then stay as just AB plus CD. Because if C is more reactive than A, there is no reaction happening. Now we have something like sodium hydroxide plus HCl will be the reaction. Well, if we go again on the reactivity series, we can know that sodium is more reactive than hydrogen, which will then mean that sodium takes away Cl, which will then become sodium chloride. And now what is left is hydroxide and hydrogen. Now, since there's two hydrogens, we'll go H2, there's one oxygen. So, we can create water. Now for the state symbols. Sodium hydroxide will be an aqueous because it's from the group 1 metals. Sodium is group 1, so this will become aqueous. Hydrogen chloride will also be aqueous because of hydrogen. Now sodium chloride is again aqueous because sodium is in group 1 metals. Now we all know that H2O is water, which will then become liquid. Here we can notice that the equation is balanced because of one sodium over here, one sodium over here, one oxygen, two hydrogens, and one chloride right here, which means this equation is now balanced. Now try these following on your own and see if you get it.
A huge thank you to you for watching. We hope this helped clear up the differences and gave you a better understanding of chemistry's building blocks. If you have any questions, feel free to drop them in the comments below. And a very special thank you to our teacher, Ms.Sosa, for watching with us. Thank you for your guidance and for making chemistry such an engaging subject to learn. Don't forget to like and subscribe for more science content. Until next time, keep experimenting.